development for working paver division. For some of you that joined us in the Paving 101 seminar last week, you will find a little bit of an overlap on our advanced paving seminar today. We will start with the basic review of the principles of the free-floating screed. We'll look at the forces acting on the screed once again, and what are the issues affecting the forces that impact smoothness and density. We will then go into segregation, typical location, causes, and solutions. And we will look at we'll take a brief look at non-contact continuous paving, some of the different MTVs out there. We'll look at longitudinal joint constructions, and then we will wrap up with automatic grade and slope systems. So let's take a quick review of the free-floating screed, the vibratory free-floating screed when it's paving. As you could see, and as we discussed in our 101 presentation, we have three forms of compaction. We have extrusion compaction as the material flows through the radius of the bull nose of the screed plate, and we have gradient compaction as the material flows through the angle of the screed, which is usually referred to as the angle of attack. Final compaction is at the trailing edge, and zero compaction, of course, is at the leading edge. So if we break the three form of compaction down on the free-floating screed, the vibratory free-floating screed, you would find the main strike-off that sits in front of the main screed controls the extrusion compaction, and those strike-offs is usually set about ½ inch above the screed plate. Then you have the gradient compaction. Some of the things that impact gradient compaction, of course, is the weight of the screed. The heavier the screed is, the more angle of attack, the more compaction. The head of material that determines the angle of attack. And the toe point position, which is basically your line of pull. And of course, how the extension screed is adjusted relative to the main screed, whether it's match height or the independent angle of attack of the extension screed. Then, of course, we have the compaction due to vibration, which is influenced by the frequency of the vibration system and the amplitude. Amplitude is generally by design and cannot be changed. Now, those are vibratory screeds. So taking a quick review of compaction screed, this is a technology that's it's been around for several years but have not taken off in North America. And today we will talk a little bit about the compaction, high compaction screeds. Compaction and high compaction screeds achieve its density due to compacting devices. What you're looking at here is a high compaction screed with three compacting devices. One in the front of the screed is called a tampo bar, and two at the back of the screed plate, which are called pressure bars. So your compaction on these type of screeds are achieved by these compacting devices and not so much bull nose or angle of attack. So the flatter these screeds pave, the more impact you will have from your tampo bars. And because you could get anywhere from 92 to 94% density with these screeds, as you could see here, we're starting at about 92% density, you have already eliminated the breakdown roller. So your rolling is dramatically reduced when you use compaction and high compaction screeds. These are asphalt screeds, so they're used in several different asphalt applications. There's some applications here in North America. That's a design build job. Same job, paving wide, eliminate joints. Thicker lift, high-end compaction, thicker lift. This is your typical mill and fill, 12, 14 feet wide, 1.5-inch overlay. But in these cases, you use a tampo bar more so than you will use the pressure bars. And of course, these screeds laid the first Formula One racetrack in Austin, Texas, which was opened November of last year. These screeds are also capable of putting down roller compacted concrete, any cold product with zero slump. Zero slump means it's similar to asphalt, so you could put it down with a free-floating screed. The only difference is it's cold mix. And your typical vibratory screed cannot achieve the same amount of compaction on cold mix as you could get with a high compaction screed. Also, the vibratory screed cannot achieve the same lift thickness as you could achieve with a high compaction screed. So you can get much thicker lift with a high compaction screed, up to 12 inches compacted, whereas with a vibratory screed, you probably get an average of 5 to 6 inches. Now, that's a little of a quick review of the free-floating screed, vibratory screed, and compaction and high compaction screeds. Now let's take a look at what holds the screed to grade whilst you're paving. So we'll do a quick review of this. There are 5 forces that holds the screed to grade. Not a mechanical lock, not a hydraulic lock. The screed is always free-floating when it's paving. And these 5 forces in equilibrium will hold the screed to grade. And the 5 forces are the pull force, which is the force exerted by the tractor to overcome all the other forces. Then you have the head of material, which is in front of the screed. And you have the weight of the screed, which of course is by design and cannot be changed on a job site. And you have the reaction force, which is the ability of the material to keep the screed in suspension or floating. And then you have the frictional resistance of the asphalt as it flows along the screed plate. So when these 5 forces are in balance, your screed will hold a consistent mat depth. If any of these forces fluctuates during the paving process for a given toe point position, a given screw position, then there will be a change in grade. So the objective whilst paving, when you are trying to achieve smoothness, is to maintain consistency in these forces. So let's take a look at some of the things that we could do on the job site to maintain consistency of the pull force, which of course is the force exerted by the tractor. So maintaining a consistent paving speed would of course be more critical. And some of the pavers today, or most pavers today, have a speed dial that allows you to set your speed. We give you the ability to set your speed whilst you're sitting so you can see how fast you're going. And then once that speed is set, then that speed takes over control of the paver, and your forward reverse lever just being used for forward and reverse and not to manage your speed. So of course speeding up and slowing down disrupt the forces of equilibrium. In equilibrium, changes in resistance of the screed against the head of material, which results in a change in mat thickness. So the objective is to set your speed and hold your speed. So you should know your job, plan the job, know how much material you can deliver to the job site, what your rolling capabilities are, and of course tonnage delivered should be equal to tonnage laid. That way you're constantly moving. There are several charts out there that you could use to assist in determining your paving speed. Now, when we stop, what happens? If you sat in our 101 course, you would remember that angle of attack changes mat depth. So every time the operator stops, he breaks the pull force, of course, and the weight of the screed sitting on the asphalt will cause the screed to settle. Some are worse than others. As the screed settles, the only fixed point as the screed is going down is your toe point. So if the screed is going down and the toe point is fixed, then your angle of attack increases. That's one. 2, the head of material in front of the screed, depending on how long you're sitting, will get cold and create a higher shear force. So a number of things come together to create a hump in front of the screed. So 1, you get a settling. 2, you get a hump. And depending on how deep the screed settled and how high of a hump you have in front of the screed, your roller generally can't get it smooth. So you will have a dent, you will have a hump, which is bad for smoothness. Now you look here, you could see the settle mark, and you can see the hump in front of the screed. Some paver have an optional screed hold, which is a hydraulic lock that prevents the screed from settling. We offer a standard feature of screed hold and a screed freeze, where the screed hold prevents the screed from settling. It hydraulically locks the screed to grade, and screed freeze prevents the screed from giving the hump in front of the screed. So it prevents settling and it prevents hump. So those are some features that we have installed on the paver to help operators minimize the impact of stopping. We know we always like to say don't stop, but there are times when you just can't help it. You have to stop. So these are some of the features that we have installed to help minimize the impact. However, the objective is not to stop. That's why we introduced material transfer vehicle to allow for non-contact continuous paving. And we will come back and review the subject a bit later. Okay, there are several different charts there for smoothness. We don't have time to cover that today, but the material transfer vehicle, of course, was developed to prevent the truck from bumping in the paver, breaking the 5 forces in equilibrium. Also, from preventing operator to stop the paver for truck exchange. So material transfer vehicles, whether it has a silo or no silo, the objective is to receive the mix from the truck and delivers it to the insert in the paver. Another impact on controlling your pull force or maintaining consistent pull force is going through radius. So your paver should have the ability to allow the operator to hold a smooth radius. Also, most important is giving the operator a string line or some sort of a steering guide to follow. Because if you can't hold a straight line or you can't hold a smooth radius, the impact will be a rough ride. The straighter you drive, the smoother your mat will be. Also, the better joint you will have, as we will review when we do a joint review of joint construction. We give the operator the ability to dial his radius using these two buttons. If he's making a left turn, you hit the left button and you will automatically create a radius as the paver moves forward. Once you get out of the radius, you hit that yellow button and the paver continues in a straight direction. So again, these are some of the features we offer to help operator maintain his consistent pull force. So as you can see, not too complicated. Just follow basic paving practice rules and you should be able to manage your pull force. Now the second most important force is the head of material. Most pavers today have systems that allows the operator to maintain a consistent head of material. That means the amount of asphalt you lay should be the amount of asphalt delivered by the paver. The amount of asphalt that the auger spreads in front of the screed should be the amount of asphalt delivered by the conveyor. So it's important to set your conveyor speed relative to your auger speed, all in conjunction with your paving speed to maintain consistent head of material. The older pavers today have flow gates. The newer pavers today, some have controls of the conveyors, some don't. The conveyor speed is regulated with the auger speed with the help of the auger sonic sensor sitting on the end gate or a paddle sensor, mechanical type sensor. So once these sensors are set, you should be able to control a consistent head of material. What should it look like? Let's see if this video will play. So that's what consistency looked like. Covering half the auger shaft, not burying the auger. The height of material in the center being the same as the height of material on the outside. We also give the operators the ability that if the sonic sensor fails, the operator will have the ability to go into the screed control and he could set his auger and conveyor speed to whatever RPM he desires based on his paving speed, paving width, until he have his sensors or cables, whatever failed, get fixed. He could do the same for the conveyor system. He could go into the conveyor screen and he could set whatever speed is required for the conveyor until the automation system is fixed. So those are some of the features, again, that we installed on the paver to help operators maintain a consistent head of material. We also give the operators a 2 digital display. These 2 bars here will fluctuate up and down as the head of material fluctuates in front of the tunnel. So when that head of material gets low, then the operator knows his hopper is empty, he needs to stop, or he needs to get more mix from his material transfer vehicle. All right, so that's force number 2. Force number 3 is the weight of the screed. This is probably one of the most confusing issues for owners and operators because most operators, most owners today prefer to have one screed for all asphalt application. That is usually a challenge because it's very difficult to design one screed that's best for all applications. And as we said, the weight of the screed is the third force, so the heavier the screed is, the more it would withstand changes or small fluctuations in the other 4 forces that are beyond our control to maintain a consistent mat depth and maintain smoothness. So the heavier screed is best suited for mainline work. You sit in the morning, you pick it up in the afternoon. But it's a disadvantage. The heavier the screed is, the disadvantage is once you make a change with your screw or your toe point, the screed takes a longer time to get to grade. As we review in our Paving 101, it takes 3 to 5 times the length of the toe arm for the screed to come to final equilibrium point after a toe point position was moved or the thickness control screws was moved. So the advantage for a heavier screed is smoother mat for mainline work. Disadvantage is not quick responding for your commercial work. So a lighter screed is a better screed for your commercial type work because it gives you quick response when you're in a parking lot or intersections or stuff like that where you're looking for quick response. So that's the weight of the screed. And then thirdly, or fourth, is the reaction of the material supporting the screed. Now, if you look at the things that impact the reaction force, it's asphalt content, temperature variation, gradation consistency. So if you keep that in mind, and we go to the last and the fifth force, which is the frictional resistance of the material as it flows under the screed plate, again, you will see asphalt content, temperature variation, and gradation consistency. But also you would find that extension screed angle of attack, the vertical position of the extension screed, the strike-off position, the line of pull, all these things also impact the frictional resistance. So at this point, we could take our presentation in two different directions. We could look at what are all the things that impact asphalt content, temperature variation, and gradation consistency, and then we will look at all the things that impact screed adjustment. So one would argue, whilst paving, how do we change the asphalt content? How do we change the temperature? How do we change the gradation? That's very simple. If we segregate the mix, then we will create a change in the asphalt content, because the asphalt is usually in the fines, and segregation basically is the larger stones separating from the fines, which is also where the heat is. So again, if we segregate the mix, we will change the temperature of the asphalt in front of the screed. And of course, segregation is larger stones separating from smaller stones. So there again, we change the gradation of the screed. So at this point, our discussion could go into segregation and into screed adjustments. So those are the next two topics we will look at. But first, let's look at screed adjustments and how critical that is. So again, reviewing the side view of the screed, you have your angle of attack, leading edge, trailing edge. But we know today we don't pave with one or a fixed screed. Mostly we pave with a hydraulic extendable screeds. And these screeds have three screed sections. So to look at, in this case, a rear mount screed where the extension is at the back of the main screed. So here, looking at the side, there's your main screed, there's your extension screed. So proper adjustment is, for an extendable screed with three sections, is to have all three sections leading edge on the same plane, and all three sections trailing edge on the same plane. If they're all in the same plane, then the trailing edge being the last point that contacts the asphalt to determine your mat thickness, then we will have a consistent mat thickness from the left end gate all the way to the right end gate. And the amount of compaction that the vibratory screed implies on the mat is from the leading edge to the trailing edge. So that mat vertical distance there is your screed compaction. So if all the leading edges of the three screed sections are on the same plane, and all the trailing edges of the three screed sections on the same plane, then the amount of asphalt getting compacted will be the same. The amount of asphalt flow under the screed will be the same, providing your subgrade, of course, is uniform from one side to the other. So it does not matter if it's front mount, rear mount, equal width, unequal width. So here we're looking at a front mount equal width, like the Blanox Omni screed. The extension front to back is 18. The main front to back is 18. The extension sits in front of the main. Again, we're paving in this direction. These are what we refer to as unequal width front mount screed, where the extension is narrower than the main screed. But it does not matter whether it's front mount, equal width, or front mount, unequal width, or rear mount screed. The principles remains the same, whereas all leading edges should be on the same plane and all trailing edges should be on the same plane. Now the match height, or vertical adjust, some people calls it, allows the operator to raise and lower the extension screed to position the trailing edge of the extension relative to the trailing edge of the main screed. Then the extension screed independent angle of attack, especially on the unequal width screed, allows the operator to position the leading edge of the extension screed to the same plane as the main screed to provide consistency on the mat surface. Now these are a couple different forms of screeds here. This is a rear mount screed. The extension, as you can see, is at the back. There's your main screed. There's your augers. There is the extension at the back. That's referred to as a main rear mount screed. But again, rigidity is very important, because rigidity will hold the extension to whatever position you put it under any paving conditions or asphalt in front of the screed. So the more rigid the extension support is, the better the operator will be able to hold his adjustment, whether he's at 12, 14, 16, 18, or 20 feet wide. So again, extension screed support is one of the most critical pieces of a screed design. And here you're looking at an unequal width front mount screed with series of 4 guide tubes supporting the extension screed. So whether it's front mount, rear mount, as long as the leading edges are on the same plane, the trailing edges are on the same plane, the amount of asphalt flowing under the screed is the same, you will have mat consistency. If the extension screed leading edge is above the main screed but the trailing edges are on the same position, then the mat thickness from end to end will be the same, but the mat laid by the extension will be more compacted than the main because you have higher in-place density because that much more material is flowing under the extension screed. So the mat depth from one gate to the other gate will be the same. There will be no lines, but you will see more of a lesser or a shadow in the form which indicates lesser density in front of the main screed because the in-place density is different because that's much more asphalt flows under the extension compared to the main, which is only that much. As you can see here, that's an indication. It's a tighter mat. It's a denser mat, higher in-place density. You can see here it looks like dragging, tearing, shadowing. That's less in-place density. So when the roller comes along, of course, you will have different level of compaction, final compaction, which results in a rougher mat. And you could see in several different cases here, that could also be a cold screed plate dragging. You could see here in the middle, there's hardly any compaction. There's more compaction under the extension. Here you can see more consistency here. And that, by the way, is a joint. That's not a line. This is one pass, and that's a second pass. And here you could see several different consistency in the mat surface texture from one end to the other. Okay, so those are adjustment of the extension screed relative to the main screed is very important to manage your frictional force and your mat consistency. With regards to adjustments, again, all screed have a main strike off, sits in front of the bull nose. That regulates the amount of flick mix that flows into the bull nose, which impacts your extrusion compaction. So the lower the strike off is, as you can see here, it's starving mix from flowing into the bull nose. So you will have a gap. The operator will crank his screw up to hold grade, and you will put more pressure on the trailing edge of the screed, which results in premature failure of the trailing edge of the screed plate. And of course, when you stop, because your pressure is only on a portion of the screed plate, you will have more settling. You will have higher humps when you take off, which will be also bad for a ride. However, if the strike off is too high, the screed will end up rolling on its nose because when you take off, the screed will tend to climb. So the operator will force the mat depth back down by turning screws to get a thinner mat, forcing the bull nose to drag on the asphalt rather than the screed floating with its normal equilibrium angle of attack or its normal angle of attack. And here you can see the trailing edge is off the mat. So that's a good indication whenever you get out on a job site. If there's daylight between the trailing edge of the screed plate and the mat, then something is wrong. The screed is not floating with its natural angle of attack. So that's how strike off impact adjustment. Line of pull is also critical. Where do you put your line of pull? It should be almost in line with the center of gravity of the screed. You don't want the toe point to be too high, neither do you want the toe point to be too low. The impact is almost the same as strike off, whether the strike off is too high or too low. So the objective is to keep your toe point in line with the CG of the screed, which is relatively close to the pivot point of the screed for most screed design. So that way you'll be pulling the screed in almost a flat position rather than too high or too low. And of course your auger should also be, the center line of your auger shaft should also be in the same line. So your head of material is also, the CG of your head of material are all in the same line with your toe point. Again, if your toe point is too low, you will force the screed on this trailing edge. And sometimes you may want to do that to tighten up your mat surface. Because if you run the toe point too low, then your mat depth will try to go down. Of course, the operator will crank his screw to get his mat depth back up, forcing the screed on this trailing edge, which sometimes help tighten up the mat surface. But too much is not too good because then you're riding on the trailing edge of the screed plate and have the same impact as you have with the strike off being too low. Likewise, if your toe point is too high, the screed will end up in its nose because when you take off, the screed will climb and then the operator will be forced to turn his screw to bring the mat depth back down, forcing the screed to run on its nose and give you again the same impact as if the strike off is too high. So how do we take off from the joint? Proper takeoff is determine your mat thickness, 1/4 inch per inch of roll down, lower your screed onto the starting blocks, pull forward to take up the slot between your pull point and your pull bracket. Lower your augers approximately 2 inches above the screed plate. Position your toe point aligned with the pivot point of the screed. Some screed you have to energize your screed to unlock the screed hole, the hydraulic screed lock if you have it. Null your screws. That means your screws should be slack or loose, which means your screed, the main screed, is sitting flat. Take up the slack with your screws and then give it 2 to 3 turns depending on whose screed or how heavy the screed is or what your mat depth is. That usually comes with experience. Fill your auger chambers and take off. So this is a recommended takeoff procedure. Some people do it a little bit different, but this usually works, and you follow these procedures, you should be able to take off from the joint with your automatic grade and slope system, whether it's a joint matcher and slope or 2 joint matchers or joint matcher and ski. So those are some of the critical adjustments that one needs to look at to ensure that the free-floating screed is paving with its natural angle of attack. Now, again, to control the reaction force and the frictional force, we talked about segregation. That's one of the things that would influence your asphalt content, your gradation, and your temperature variation. So what is segregation? Segregation is larger stones rolling away from smaller stones. When that happens? Of course, whenever you create a sloping face. Now, seeing that we don't manage the plant, we're only dealing with the pavers, so we will not be looking at any segregation or potential segregation that could be created at the plant. We'll be only looking at segregation from the truck, when the truck delivers into the paver, when the paver delivers to the screed, or when the material transfer delivers to the paver. So as we said, if you create a sloping face, you will have the larger stones on this face roll down, gather into the valley there, and you'll have a pocket of segregated mix smack in line with the center of the conveyor. Likewise, you would have on this side. So segregation we could look at in the paver hopper or while delivering mix from the paver tunnel to the screed. So these are the 2 forms, in the hopper and when the tractor delivers to the screed. So in the hopper is when the truck delivers it to the paver, or also as the conveyor chain is dragging it to the screed. It all happens in the hopper. Now, if you look at segregated mix in the paver or in the hopper, if the operator dumps the hopper and you have segregated mix in a corner, you dumped it to the middle of the hopper, that segregated mix flows into the augers and the auger will start to spread it as you move forward. So if you noticed a chevron or a V where the tip of the V is in the direction of paving, then you would know right off the bat that you're dealing with segregation in the hopper. But the most important thing is to be able to identify mat flaws, whether it's screed related or segregation related. Because too many operators today can't identify the difference between flaws in the mat, whether it's created by segregation or created by screed adjustment. And if you can't do that, it'll be real difficult to resolve because you wouldn't know where to start. So if the flaws in the mat looks like it's an open texture, you can see the larger stones on the surface, and we're not talking about thermal segregation here because that will be a subject for a different day. We're looking at visual or mass segregation that's visual on the surface of the mat. So if it's open grade, it means you're dealing with more of a segregated type of flaw. As opposed if you're seeing shadows or lines, it could be more of a screed related issue rather than segregation. So if you see the tip of the V in the direction of paving, then right off the bat you should know it's a chevron created by segregated mix in the hopper. If you notice 2 open tier in the center of your tunnel, in line with the center of the tunnel on the mat, then you should know that you're running your hoppers too low, you're not dumping adequately, but you also have to be careful with some state specs where you're not allowed to dump your hopper, mainly because they're trying to prevent these type of segregation. So if you run your hopper too low, you created a valley in the center of each conveyor, and you will have segregated mix rolling to the middle, and you will see that in the center of the conveyors if it's on the left or the right side. As you can see here, segregated pocket of mix there, segregated pocket of mix here, and that of course will create, if you dump all of that into the middle, you will have these chevrons as you can see here. And you could also see here, these are all truck end segregation, which of course is bad for the lifespan of the road, because the fines is where the asphalt is. So if there's no fines in this area here, there's nothing to hold a larger aggregate together, so that will be your first point of failure. And here's what you get if you run the hoppers too low, as you can see. In this case here, if you keep on running that conveyor, then that pocket of mix will get onto the mat and give you a blemish, an open tear in the center of the conveyors. Now there are several different procedures for truck end segregation, and you can go online and you can look at NAPA TAS 32, which is proper truck exchange. That's pretty much basic Paving 101 type of information, so we will not cover that today. But if you're interested, you could go to that article there. It's a paper written by NAPA TAS 32, and that will give you proper truck exchange procedure. Now, one of the most ignored piece in our industry today is when the material transfer vehicle is feeding the insert in the paver. And here you could see a large pocket of segregated mix. And what happens to that mix there now, it will drop, slowly drop. It will hit the sidewall of the insert, which sits in line with the edge of the conveyor tunnel. And then that segregated mix will end up at the edge of the conveyor and eventually close to being under the bearing hanger. And the the blemish on the mat will appear close to being under the bearing hanger, and in most cases being interpreted as being segregation created by the bearing hanger, whereas it's basically created by this sloping face here, where this pocket of large aggregate rolls down and hit that side face. So let's see if we can see a quick video of that happening here. Now you can see that blemish right there and right there. So that there is segregation created in the hopper insert. So one should take proper care and choose the right shape of insert and proper loading practice to eliminate segregation created in the hopper insert. Now let's look at segregation that occurred when the tractor is delivering the mix to the screed. And these are all your typical form of segregation. It's your center line, which is the worst because there is no augers in the center of the auger box. So there's generally 15 to 18 inches of dead spot under the bearing, under the auger box that leaves segregated mix in the center. Then of course you have segregation at the outer edge of the tunnel, which usually are caused by in the insert, as we just see. And you have segregation at the edge of the main screed, which is generally at the end of the augers. And you can also have segregation at the end gate, which is also bad because that could be your joint. And if you have segregation at the end of each pass, then the joint will be filled with segregated mix. So these are some of your typical segregation: center line, at the edge of the tunnel, at the edge of the fenders, at the edge, end of the material roll. So how do we address some of these forms of segregation? These are generally features that are designed on the tractor and the screed to minimize those types of segregation. Independent auger and conveyor drive is one typical feature on today's design. Most pavers have now eliminated the flow gate and allow the operator to independently control the auger and conveyor to better balance his head of material. Automatic conveyor sensors, automatic auger sensors, these are things that should be functioning to allow the amount of mix delivered to equal to the amount of mix laid by the screed. Auger extensions beyond the bearing hangers to help that mix move freely under the bearing hanger. Adjustable pitch auger flights, material chutes under the conveyor tunnels. These are all things that helps the material flow. And here you could see the independent auger and conveyor drives. Some of the older pavers today had a D-drive box, where this would be a wall attached to the tractor so that it would be difficult to feed mix under the auger box. As you can see here, these augers with this box being very narrow, these flights here pushes mix under the box to help minimize that center line segregation. Adjust your flow gates properly, or set your conveyor sensors, your paddle sensors, such that the conveyor delivery is equal to the auger delivery, which is equal to the amount of mix being laid, so you have a consistent head of material. Position your auger sensors such that your augers are continuously turning, not stopping and starting, because every time the auger stops and starts, it fluctuates the head of material and have an impact on your smoothness. Extensions, auger extensions beyond the bearing hanger that helps move the mix under the bearing hanger and reblend some segregated mix that may come out of the outer edge of the conveyors. Quarter flights that helps move the mix under the auger box. If you take a quick look at this video, it may be dark and difficult to see, but you can see the larger stones getting gathered in the middle right there. That's your auger box right there. And you can see the mix coming from each corner of the augers and collecting to the center. There's your larger stones. And that there by itself will create centerline segregation, which will be the weakest point of the mat. So have proper flights close to the auger box adjusted such that these flights move the mix in this direction, whereas these flights moves the mix in this direction, pushing it under the auger box. Likewise over here. But it's always better to flush the mix from under the box rather than having both flights tucking mix towards the middle. Because that's what you saw in the video, is these two flights moving mix to the middle and pushing all the segregated stones smack in the middle. It's always better to have one flight in the opposite direction, forcing the mix under the auger box to flush any potential segregated mix at that point. So proper truck exchange, again, TAS 32 will teach you how to manage your head of material. There are different types of material transfer vehicles out there that helps you to transfer that material to the paver to minimize segregation. These are called pickup machines. They usually pick up a windrow that are created by belly dump trucks and then deliver it to the paver. Today we have material transfer vehicles, belt type conveyors and chain type conveyors that receive the mix from the truck and delivers it to the paver. So those are some of the things that you could do to minimize the different form of segregation that create wall swore paving. Now, building a sung longitudinal joint, we'll look at quickly, and how do we create proper longitudinal joints. Now, most of these information was created by NAPA. These are not Work in America or Vogla information. This information came from NAPA training, so I'm basically passing it on. Control segregation on the outer edge of the mat. Steer a straight line. Again, you can see how important it is to steer a straight line. It's not only for smoothness, but it's also to maintain a proper joint. Compact unconfined edges, maintain proper overlap, another controversial subject. Some people are doing things a little bit different. Place proper depth for roll down. Do not loot the joint. Compact the joint for proper density. So let's look at these one by one. Use auger extensions where you can to help move that mix out, but also be careful because you can see segregated mix out there, which is right at the joint. So use proper auger extensions to allow the augers to move the mix and not let the mix flow naturally, because that's when you have a higher probability of segregation. You can see there very ununiform line, and you can see here nice straight line, which creates better joint. When using pneumatic rollers, try to stay away from the edge of the joint at least 6 inches. Make sure you have your proper pressure. Overlap 1/2 to 1.5 inches. Roll down starts with roughly 25% of the mat depth. If the overlap is correct, little or no handwork is required, as you can see. So that means if the overlap is correct, you should not have to loop the joint. What luting does, it removes the material away from the joint and it creates a void. So if you have proper overlap, you should not have to touch the joint, and you should end up with a better joint. Rolling hot to cold. On the hot side, you leave roughly 6 to 8 inches on your first pass. On your second pass, you overlap 6 to 8 inches on the cold side. So on your first pass, if you stay inside 6 to 8 inches from the cold joint, then you will have a little bit of a hump of an asphalt created there on your first pass. Then on your second pass, you will compact that, creating a higher density at the joint. So those are some of the practice for proper longitudinal joint. We could take a quick look at the different type of automation system today. We will not go into details because of our time frame, but there are different types of automation system there. Vogel and Nivlotronic, which is built into discrete control. You have MOVA system, which is an external control box mounted on the paver. And you also have TopCon, which is an external box mounted on the paver. All these systems performs very close. The difference is which one is more user-friendly than the other, and some are more reliable than others. Those are the difference. But in terms of smoothness, holding smoothness, performance, they're all pretty much the same, or very close. Joint matcher. So we say single grade control used to precisely follow a known reference. That is usually referred to as a joint matcher. You could follow an existing joint. You could follow a curve. You could follow a string line with all the different type of sensors to hold your mat depth on the grade side. Your grade control sensor, where do you position it? Usually the best place is in the center line of the drive wheel or the drive hub in the case of a track paver. It's always easier to mount it on the end gate because then it moves in and out with the end gate, but one has to be very careful when you position your joint matcher on the end gate. If you're paving on a road with a severe crung in it and you move your end gate in and out constantly because the operator was not holding a straight line, every time you move the gate in and out, then your incline on the crown will have an impact on the mat depth and end up in a rougher mat. In those cases, in situations like those, it's probably better to mount your joint matcher on the toe arms. Different types of non-contact sensors out there. TopCon's got one, MOVA's got one, we have one. Recommendation for the distance from your sensor to your reference point, 18 to 22 inches, depending on whose it is. But again, the position is in line with the drive wheel or your drive hub on a track paver. There's also mechanical type sensor. The position is the same, but in this case it drags on your reference point, whether it's a string line or a curb or an existing joint, but the performance are generally the same whether it's contact or non-contact. Averaging ski, if you guys remember our presentation from Paving 101, the averaging ski is used to average irregular contour of your base. And in your automation system, if it's a contact ski, the joint matcher basically will read off the beam of the ski or a string line attached to the beam. So that there is a contact ski being dragged by the paver using a joint matcher to follow the ski as its reference point. Here's another type of mechanical ski. These are older technology and becoming obsolete. You have today contact skis, or non-contact skis, sorry, where the beam is attached to the toe arm, and then you have the same joint matcher type sensor, whether it's 3 or 4, depending on whose sensor it is, measuring the distance at each point and then creating an average, give you your final average point to maintain your smoothness. These beams could be, depending on whose, anywhere from 15 feet to 50 feet long, and depending on the state, you could require 30 to, I see as long as 60 feet long in some cases. So those are your non-contact averaging ski. Some TopCon or TS no longer exists, but TopCon makes a non-contact ski. MOVA makes a non-contact ski. Vogel also makes a non-contact ski. So those are some of the different types of automation that we use, and that will be the end of our advanced paving presentation today. And I'll